Greetings and hello everyone. Today's lesson is on solving absolute value inequalities. So let's start off with a learn. So when solving absolute inequalities, there are two cases. So case one, the expression inside the absolute value symbols is non-negative. So that means it's positive. If x is non-negative, then the absolute value of x equals x. Case two, the expression inside the absolute value is negative. So if x is negative, then the absolute value of x equals negative x. So we have these two cases, and you'll notice that this is for intersection. So let's try out an example with these two cases. So much like two cases for solving absolute value equations, we have two cases for solving absolute value inequalities. So we're going to have case one, and we're going to have case two. So we want to solve the absolute value of m plus 5 is less than 3. Then we want to graph the solution set. So let's start off with case 1. What happens if it's non-negative? So if it's non-negative, we would get m plus 5 is less than 3. I want to solve this inequality. So I solve this inequality by getting m by itself. So I'm going to subtract 5 from both sides. Because by subtracting 5, that's doing the opposite of adding 5. So it's going to give me m is less than 3. Case 2. Now this is negative. So this is going to give me negative m plus 5 is less than 3. So I multiply through by a negative. So negative times a positive m is a negative m. Negative times a positive 5 is a negative 5. And that's going to be less than 3. So now I'm going to solve this inequality. So I solve it by adding 5 to both sides. So that gives me negative m is less than 8. Oh, this isn't negative 3, sorry. This is going to be negative 2. Now I'm going to divide through by a negative 1. divide through by a negative 1. Since I'm dividing through by a negative 1, I'm going to flip this sign. So when I do, that's going to give me m is greater than, positive divided by a negative is a negative. 8 divided by 1 is 8. So the solution set to this, again, they want a graph, but we can still put the solution set. So the solution set is any value of m such that negative 8 is less than m, which is going to be less than negative 2. And let's graph that and see what we get. So I have 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So it's less than, open circle, greater than, open circle, and we're going to shade everything in between, because those are all possible solutions to this inequality. Let's take a look at example 2. Again, this is very similar to what we did with compounds. We're going to have two cases, and then we're going to solve it out. So here it says solve. The absolute value of n minus 1 is going to be less than negative 5. Then graph the solution set. So we have an issue here, less than negative 5. So it is not possible for the absolute value of n minus 1 to be less than negative 5. Therefore, there is no solution. The solution set is empty. Another name for this is the solution set is empty. So we can't get that expression right there to be negative 5, so that's why it is not possible. So let's take a look at a word problem, because this is where we encounter such problems in the world. Jones is a software developer who wants to determine whether the change he made to his programs are popular with users. He releases a survey to get some feedback and finds that 72% of users like the change. So 72% of users like the change. The margin of error is within 1.18. So error within 1.18, which means that that is a reasonable level of certainty. The actual percentage could be said to fall within 1.18 of 72%. So what would this be? What would be expected percentages for us to fall in? So what is going to be the bottom percent that we can fall in, and what is going to be the top percent that we can fall in? So the inequality statement is the absolute value of x minus 72 is going to be less than or equal to 1.8, because that's our margin of error that we're falling in between. So case 1, what happens if this is a non-negative value? So that means x minus 72 is less than or equal to 1.8. So I add 72 to both sides, and I get x is less than or equal to 73.8. So our top percentage would be 73.8. Case 2. What if the expression in here is negative? So that would be negative x minus 72 is going to be less than or equal to our margin of error, which is 1.8. So distribute in that negative. That gives me a negative x. Negative and negative is positive, so that gives me a positive 72 is less than or equal to 1.8. Subtract 72 from both sides. That gives me negative x is less than or equal to negative 70.2. Divide by negative 1. I'm dividing by a negative 1, which means I need to flip this sign. That results in an x is going to be greater than or equal to 70.2. So my lower percent is 70.2. My higher percent is 73.8. So I'm going to fall between 70.2 and 73.8. I'm going to have values of x such that I fall between that interval. So that's absolute value that falls under intersections. So the next one, we want to look at another learn. So when absolute value inequalities are solved, we have two cases. Case 1. The expression inside the absolute value is non-negative. So if x is non-negative, then the absolute value of x equals x. Case 2, as you might think, what happens if it is negative? The expression inside the absolute value is negative. So if x is negative, then the absolute value of x equals negative x. So the last one was on intersections. This one's going to be on unions. So let's take a look at what a problem looks like using this idea with unions. So we want to solve the absolute value of 2m minus 9 is greater than 13. And we want to graph the solution set. So again, we have two cases. Let's start off with case 1. So I have, if it's non-negative, so 2m minus 9 is greater than 13. So I'm just going to solve this. So I solve this by adding 9 to both sides. So that gives me 2m is greater than 22. And then I divide by 2. And I get m is greater than 11. So that's case 1. What about case 2? Well, with case 2, our expression inside the absolute value is negative. So this is going to give me a negative 2m minus 9, which is greater than 13. So distribute in that negative number. So that gives me negative 2m plus 9 is going to be greater than 13. So I'm going to subtract 9 from both sides. So minus 9 gives me negative 2m is greater than 4. Now I'm going to divide by negative 2. But I'm dividing by a negative. Since I'm dividing by a negative, that means I'm going to have to flip this inequality sign. So that's going to give me m is now less than negative 2. So m is greater than 11, but m is also less than negative 2. So we can write this as a solution set, kind of like an in-between, but we need to graph this. So we want values of m such that m is greater than 11 or m is less than negative 2. Again, this is like an in-between set. I need to graph it. So let's graph it. So I have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I want values that are bigger than 11. So it's going to be an open circle at 11 because it's greater than 11. And I want values that are less than 2. Again, another open circle because it's just less than, and then less than 2. And that would be the graph for this absolute value inequality. Let's take a look at one more problem. So example 5, solve the absolute value of n minus 6 is greater than or equal to negative 5. So let's start off with case 1. What happens if it's non-negative? So case 1. Notice that this time it's greater than negative 5. That's why we can do the two cases. Where on the previous example, it was less than negative 5. And that's where we were getting stumped on. So n minus 6 is going to be greater than or equal to negative 5. So I'm going to add 6 to both sides. So I get n is greater than or equal to 1. Case 2. What happens if the expression in here is negative? So it's going to give me negative n minus 6 is greater than or equal to negative 5. So distribute that negative to the n and to the negative 6. So that gives me negative n plus 6 is greater than or equal to negative 5. Now I'm going to solve this inequality. So I subtract 6 from both sides. So I get negative n is greater than or equal to negative 11. Now I'm going to divide through by a negative 1. But because I'm dividing by a negative, I need to flip this sign right here. And when I do, I get n is less than or equal to 11. So n is greater than 1. So that means we're going to shade everything to the right. N is less than 11. That means we're going to shade everything to the left. Wait, we're shading over each other. Again, because 1 is right here, shade everything this way. 11 is right here, shade everything this way. And this is a union, so we're going to take everything. So we're actually just going to take this entire number line. We want values of n such that n is greater than or equal to 1, or n is less than or equal to 11. So this means our solution set is all real numbers. Because it's the entire number line that we're going to take, because it's a union, so it's or, so we're going to either take numbers that are greater than 1, or we're going to take numbers that are less than 11. So those two put together create the entire number line. Go ahead and review through the problems for today, and have a great day.